Use integration by parts to show that given integral is equal to this expression. So since it's specified that we should use integration by parts, we need what? We need u and v prime to be chosen. And we should consider this expression as a product of two functions, and definitely we can split it into sine and cosine multiplied by negative sign. Why? Because and actually u must be sine v primed cos of x e to negative sine. Why? Because you need to find integral here, and you can see that it can be used as substitution u. Why? Because derivative of sine is cosine, and you will get e to negative u du. And you should understand that, or actually how to understand that substitution u can be applied. Integral cos e to negative sine dx, you can see that derivative of sine is cosine, and hence you can see that we get in terms of sine only, and it's actually our substitution, our u value. It looks like e to negative u du. It's called the inverse chain rule, but it's not required. You may apply substitution u method directly, but it's useful to understand that some substitution can be applied at all. So u derivative, it's what? Sine derivative, just cosine, and v, it's integral of cosine e to negative sine dx. If you can understand it directly, it looks like what? It's derivative of sine, so it looks like e to negative u du. If it's difficult, you use as usual. You write, you don't get confused, it's another u. U, it's what? Usually we substitute it more complicated argument. If it's function of more complicated argument, we choose u to be this argument, so u is negative sine. The next step is, as usual, du over dx, it's negative cosine, so dx is what? Du over negative cosine. So this integral becomes integral cosine. We don't hurry up because it's difficult to substitute in terms of u, and we know that this method usually gives that such terms cancel, so we don't hurry up to replace it in terms of u. So cosine e to the power of what? U, and dx is what? Du negative cosine of x, and cosine cancels, and we get negative integral eu du, which is what? Just eu, and with minus, so it's negative, and u is negative sign, so negative e to the power of negative sine x. And continue integration by parts. So this integral sine cosine e to negative sine x dx is equal to what? uv, this product, so it's sine x multiplied by what? Negative e to negative sine x, and minus integral of this u prime v, so minus integral cosine times what? Negative, so it's plus e to negative sine x dx, and this is equal to negative sine x e negative sine x of x plus, and to find this integral, it's also substitution u, and also you understand that it looks like e to negative sine derivative of sine, and it will be minus e to negative sine, or again u is what, negative sine, du over dx, it's what, negative cosine, hence dx is what, du over negative cosine. So this integral becomes cosine e to the power of u, and dx is du negative cosine, and it's what, it's negative e to the power of u, so negative e to the power of u, which is negative sine x, and we can factor out e to the power of negative sine of x, and it becomes what, and also we can factor out negative 1, so it becomes 1 plus sine and plus some constant as required. The next, consider the following equation: dy over dx minus y times cosine is sine times cosine. Find an integrating factor. So you understand that it's about what, solving the differential equation by integrating factor. And first of all, you should understand clearly that the form of such differential equation must be exactly like y derivative plus something of x times y is something of x, and if there is some additional in terms of x in front of y here, dy over dx, you should divide each term by this to get directly like this, of such form, because a method can be applied only when the differential equation is like this. So, and the integrating factor is equal to e to the power of integral p of x dx, and p of x, it's what, it's negative cosine, it's negative cosine dx, and it is equal to what, e to the power of sine, but sine derivative is cosine, we need negative cosine, so it's negative sine, and it's the required integrating factor. C. Solve the differential equation given that and answer in the form. Okay, so how to solve this by integrating factor? The next step is what? We multiply by this integrating, we multiply each term by this integrating factor, and you must write this. So it becomes e negative sine of x dy over dx minus e to negative sine of x cosine, and the y is e to negative sine of x sine cosine, and there will be always the same, the left hand side, therefore it becomes it's d over dx of our integrating factor multiplied by y. It always will be true because the method, and is equal to sine cosine negative sine of x, and hence integrating both sides, or if it's a derivative of something, this something hence just integral of this sine cosine e to negative sine, and just using the previous result, which is what? Oh, actually it is given here. It's minus e to negative sine of x multiplied by what? 1 plus sine and plus constant. We can find the constant here, or solve for y and then find a constant. So it is given a point. What point? 0, negative 2. And e to the power of 0, it's 1, so it's negative 2. It's what? Minus here. 1 plus constant. Let's check. 1 multiplied by 1. Okay, so constant is what? Negative 1. And hence y is, it's negative 1. So y is multiplying each term by e to the power plus sine, so that e to negative sine multiplied by e plus sine is just 1. And it will be minus 1 plus sine and negative this 1 e to the power sine x. And it's the required solution in the form y is f of x minus, it seems to be correct. And that's all for this question. Or maybe additionally about inverse chain rule, how to understand that substitution you can be applying, how to do it quickly. For example, it is given integral x or tan x e to the power of negative x squared plus 5 dx. You understand that derivative of x squared is x, but we should fit coefficients, so, and we can consider derivative of negative x squared plus 5. And what is derivative? It's negative 2x, derivative of 5, it's just 0. So you can see that if you take derivative, negative 2 arises. So negative 2 arises. Or negative 2x goes under d. Or when you take a derivative again, negative 2 arises and you should compensate it. So it becomes just 10 divided by negative 2 e to negative x squared plus 5 d of negative x squared plus 5. And it's our substitution u, so it becomes negative 5 e to the power of u du. Or integral sine over cosine dx. Derivative of cosine is negative sine, so additional minus arises, so we should compensate it. So it looks like derivative of cosine, but it will be negative sine, but we have sine only, so we should write minus cosine, and you can see that it's what? Minus du over u. And that's all for this question.